Assalamualaikum and greetings to Madam and my fellow friend. Today, I'm from the group that make case study for Geotechnical Engineering DCC30093. Our group contains of 5 members. First is Cuthbert Savio Primus. Second is Emmanuel Anthony. Third is Aaron O'Neill Clifton. Fourth is Muhammad Ashraf bin Sharifuddin. And last is me, Bintang Rizky. 1.0 Introduction. 1.1 Definition of foundation. The lowest part of structure in the direct contact with soil, transferring load safely. 1.2 Classification in foundation. Swallow is transfer loads to a swallow tantrum. Deep, meaning transfer load to deeper depth, crucial for tall structure or weak soil. 1.3 Construction process. First are trench digging, reaching a stable stratum by digging trenches. Second, concrete pouring, stirring the base with the poured concrete. Third is reinforcement, incorporating steel rods for structural integrity. Last but not least is building initiation, starting construction once the foundation is packed correctly.
So I will explain for 1.4 material and type selections. There are 3 of them. The first one is dependence on design lots and soil types. This selection is based on these structural factors. For number 2, environmental impact consideration. Design must account for construction effects on the environment. The last one, adverse effect awareness. Digging and piling for deep foundation can cause soil and structural issue nearby. So next, 1.5 Importance of proper foundation. There are 3 of them also. The first one is structural stability. The foundation as the backbone of stability. Next, substructure development enables development of a firm base, preventing lateral movements. And the last one is uniform load transfer for prevent unequal statement and differential effects on building. So let's move to the next slide is 2.0 objective. 2.1 Identifying root cause. A. Pinpoint specific factors leading to foundation failure. B. Explore soil condition, construction practice, and related variable. 2.2 Recommendation strategies. A. Develop actionable solution to address identified issue. B. Engineer interventions, drainage enhancements, and stabilization measure. And then last one, 2.3 Lesson learned. Summarize key takeaways for future projects. And B. Share insight to prevent similar failure. Best practice, set assessment and preventive measure. And the next slide is 3.0 Classification and function of foundation. 3.1 Type of foundation. There are many types of foundation. For the first one is strip foundation. Strip foundation is wide load distribution across an area. The second one is rough foundation. It's cover entire building footprint for stability. And then pile foundation, deep columns for heavy load. After that, slab on grade, direct concrete slab on soil, common in homes. After that, caisson foundation, deep stability through drill shaft. After that, pier foundation, support localized load through columns. And then we get T-shaped foundation, mix of strip and slab for added strength. And then footing or foundation wall, laterally resistant and load support. After that, mat foundation, thick slab for uniform support. And for the last one, isolated footing, support single columns or load bearing members.
Now, I'll continue the presentation with the purpose and importance of foundation. First is load distribution. Evenly distributes building weight to prevent settlement. Second, stability and integrity. Ensures stability, avoiding sinking or tilting. Next, settlement prevention. Minimizes uneven settling, maintains structure stability. Next, moisture protection. Shields structure from ground moisture, preventing damage. Next, seismic resistant. Absorb and dissipates seismic forces for resilience. Next, elevation and frost protection. Protect from flooding and frost heave. Next, support for walls and columns. Provides a solid base for upright load-bearing elements. Now, I'll continue my presentation with case study background. First, introduction to incident. Partial collapse of a condominium in Taman Desa, Kuala Lumpur. Suspected cause, structural failure rather than weather-related factor. Mention issues, potential flaws in the building structure, including foundation, beam, and column. Causes of foundation failure. Possible reason, foundation, beams, or columns not meeting specification. Ongoing investigation by contractors and the Department of Occupational Safety and Health (DOSH). Emphasis on enforcement, check, and adherence to approved building design by Khalid Samad. Understanding potential foundation failures. Factor contributing to foundation failure. Subpart materials not meeting standards. Construction method causing discrepancies. Insufficient reinforcement, compromising structural stability, design not aligned with load-bearing requirements, importance of quality control, adherence to guidelines, and rigorous check emphasizes to prevent vulnerabilities. Next, I'll give my friend to continue the presentation.
5.0 Case Study Analysis. 5.1 Analysis Summary. The first one is probable structural failure due to compromised analysis and design methods. Next is Federal Territories Minister highlighted potential issues with foundations, beams or columns not meeting specification. The next is collapse occur during heavy rain, triggering investigation by DOSH, DOSH and contractors. The next one is enforcement and checks highlighted as crucial by Minister Khalid, placing responsibility on the Kuala Lumpur City Hall. The priority areas of concern. The first one is weak pile foundation. It is because inadequate strength to support building weight. The second one is insufficient footing, lacks strength to handle the load. And the last one, strip foundation inadequacy. It is failed to distribute building load, causing sinking and collapse.
These are the picture of the foundation structural failure at Taman Desa. Recommendation for improvement enhancing geotechnical engineering practice. The first one, thorough site assessment. Conduct comprehensive geotechnical investigations pre-construction, considering soil conditions and environmental factor. The second one is implement monitoring system. Utilize advanced system for early detection of structural distress or foundation instability. The next is professional peer review. Introduce rigorous external evaluation involving geotechnical and structural experts. The next is regular maintenance inspections to establish routine checks to address any changes in the foundation over time. The next is continuing education. Promote ongoing education for engineers to stay updated on the latest advancement. And the last one is collaborative design approach. encouraged interdisciplinary collaboration among engineers, architects, and builders.
We have come to our conclusion, and here are the findings that we found on condo foundation failure in Taman Desa. Firstly, root cause. This is due to structural inadequacies, although there are no external factors such as heavy rains or landslides. Next, which is minimal role of selected slope. The authorities confirm limited impact. Thirdly, collapse timing. It will occur pre-rain, highlighting potential weakness in foundations, beams or columns. Lastly, emphasis. Its crucial adherence to design specification and rigorous construction checks. Next, we go to the recommendations for future works. Firstly, comprehensive site analysis. This is to conduct extensive geotechnical investigations for holistic site understandings. Secondly, advanced monitoring systems. To implement cutting-edge monitoring to detect structural distress early. Thirdly, external peer review. Engage as geotechnical and structural experts for impartial assessments. Fourth is regular maintenance and inspections by establishing a post-construction inspection schedules for early issue education. Fifth, continuous education and training. This is crucial due to provide ongoing education for geotechnical engineers on latest practices. And last but not least, enhanced enforcement to strengthen the mechanism to ensure strict adherence to approved designs. That's all from us. Thank you.